3.2 Another application. A boat left Sunny Point Marina at 11 a.m., traveling at 10 nautical miles per hour. 2 hours later, a Coast Guard boat left the same marina traveling at 14 knots, trying to catch the first boat. If both boats traveled at the same course, at what time did the Coast Guard captain anticipate overtaking the first boat? All right, so we have the first boat, and it's traveling. It's leaving Sunny Point Marina, we'll say that's here, and it's traveling at 10 knots, which means nautical miles per hour. Notice that that's going to be the rate of the first boat. Then we have the second boat, which is actually the Coast Guard. The first boat may have done something bad. And it's traveling at a rate of 14 knots per hour. Oh, sorry, knots, which is the same as nautical miles per hour. I'll just write those differently, but they're the same unit. And that's the rate. So these are both the rates. And the time traveled by the first boat will be t. And we know that the second boat leaves 2 hours later. So the time for the second boat will be t minus 2. That's the Coast Guard. Okay. And the question is, let's see what the question is. At what time does the Coast Guard captain anticipate overtaking? Is it going to catch up? Now we need to remember that rate times time equals distance. And when this second boat catches up with the first one, they will have traveled the same distance. So let's think about the first boat first. It's going to be traveling, let's use rate times time equals distance, at a rate of 10 nautical miles per hour at a time of t, and it's going to travel d, and the Coast Guard is going to leave at 14 knots, traveling t minus 2, and that has to be in parentheses. That's the rate times time for the Coast Guard, and that will be distance. And we just mentioned a second ago that when the Coast Guard catches up with the first boat, the distances will be the same. So we can use that fact to make these equal to each other. So if you wanted to write this as a system of equation, you would have 10t equals d, that's the first boat, and 14t minus 2 equals d. And so what we're really doing now is we're doing substitution. We're going to take the second equation and we're going to replace the d, substitute in this other equation, 10t. Okay, so we're solving the system using substitution, and we go ahead and solve this, and we multiply this through. First we get 14t minus 28 equals 10t. And then I think I'll add 28 on both sides and subtract the 10t on both sides. Do this all at once, and I'll have a 4t on the left, and this added to the other side will give us 28. I had to add it over here also. And so 4t equals to 28, so we divide both sides by 4, and t will equal 7. T is the time, so 7 hours is the time traveled by the first boat. Now, what was the question again? If both boats traveled the same course, at what time? Okay, you don't answer 7 hours. At what time did the Coast Guard catch up? Well, we know the time will be 7 hours after the first boat started. So it started at 11 a.m. and 7 hours later, that would be 6 o'clock. Well, 1 hour will get us up to noon, and then we have 6 more hours. It will be 6 p.m. when the Coast Guard catches up. Sorry, I had that too low for you. I'll move it up, and you can pause if you need to copy that. It will be 6 o'clock p.m. when the Coast Guard catches the first boat.